In this video, I'll show you how to pull and push changes to a remote GitHub repository using either the Git desktop client, Terminal for Mac, or Git Bash for Windows. First, what we'll look at is a couple of remote repositories on the GitHub website. One of them is from darkmarks.do. That's the true state of the project that I want to contribute changes to. But on GitHub, I'm a user called Strawstack, so I can't make changes directly to darkmarks.do. But what I can do is click the fork button and fork the repo to my account. Once the repo is forked, I have a second copy of it called strawstack/bricks. I have full control of strawstack/bricks, and I can pull and push changes as I would like. In a moment, I'll review how to make changes to a repository. Once I've made my changes, though, I can get them to this remote repository and then click the New Pull Request button to allow darkmarks.do to accept my changes into the main project. This next part of the video has lower audio quality because there was a fan in the background. Whether you're using the terminal on Mac or Git Bash on Windows, the commands will be the same. The first command that I type is git clone. Git clone takes a third argument, though, which is a URL. That URL is the URL of the project that I want to clone. I can get this URL by clicking this clone or download button and grabbing this URL here. It starts with HTTPS. I paste that URL here, and the command git clone URL, and I press enter. It will clone the project to the current folder that I'm in. Right now I'm on my desktop, and so we've seen the project has appeared here, and it's just about finished downloading. The project is finished downloading now, and I can open the folder and see that all the files that were on GitHub are now on my local computer. I can treat this folder just like I would any other folder on my computer, and I can make changes. But the interesting thing is that when I go into the folder, once I'm in the project, I can run commands like git status. And it'll tell me that the local changes to this folder are the same as the changes that are on the remote. I can say git log to see a listing of the most recent changes that were made all the way back to the beginning of the project, to the first commit. So the commands I've just shown you are git status, which tells you the current status of the repo, what branch I'm on, and whether I'm behind or ahead in commits. I can say git log, which tells me a list of all the commits that were made ever in this project in chronological order. What I'd like to demonstrate now is the difference between a local repo and a remote repo. Git has a concept of something called remotes. Right now, I'm working in a terminal in this folder. But I can ask GitHub if this local folder has any remote repos that it's connected to. I can say git remote show, and it will tell me that there's something called origin, which is a remote repo, which in this case is the one on GitHub, that GitHub will automatically, that when I make changes to this project, commit them and push them, it may go to origin if I tell it to. I can ask Git to tell me the URL of this. I can say git remote show origin, and it'll tell me where this local repo is connected to. In this case, I'm going to demonstrate an extra step now, which I hope might give you a deeper understanding of Git. If I look at my repo here, I have a total of 9 commits. But the user that owns this project has 10 commits. This 10th commit is different than the one that I have on my branch, but every other commit is the same. When I forked the repo, there were only 9 commits, and this was the final one. But now, when I look at the commits, there's one more extra one that's different from the history that I have. And so what I would like to do right now is tell GitHub to take the most recent version of this project and bring it and then update my fork of the project with the most recent version of this project. And this is how I'm going to do that. I'm going to issue a command to GitHub that tells GitHub about this remote repository. Right now it knows about this one. It's called origin. Origin is the remote repo for my local branch, for my local repo. But I want to tell GitHub that this repository is also a remote. But not only is it a remote, it's a special kind of remote. It's the upstream repository from this remote. So just to review, I have a local branch here that interacts with this remote repository. But this repository is considered to be downstream from this one. Changes to the project occur here, and this is the true state of the project. I want to take that true state and update my remote repository with it. But then I want to take these changes and bring them to my local repository, and vice versa. When I make changes here, I want them to show up in my repository, I want to push them to my remote repository, and then I want to make a pull request to go upstream so the changes make their way to the actual project. So what I'm going to do right now is issue a command to my local repository using the command line that tells GitHub that this is the upstream repository, which is the actual true version of the project. So as we saw before, I have origin. I want to add another remote repository with whatever label I want. I'm going to say git remote add upstream. That's going to add another remote repository called upstream, similar to what I have with origin. But this time, I'm going to give it a different URL. I'm going to give it the URL for the true project owned by a different user on GitHub. Now that I've issued that command, I can say git remote show again, and it tells me I have an origin and an upstream. When I ask Git to show me the upstream, I get these URLs, which are the URLs for this project. So now what I can do here, when I'm in my local project, and what I want is to update my local project with the most recent changes from this user's repo, from the actual project. So what I'm going to do is tell Git to pull those changes from the upstream to a branch called master. I'm going to tell Git to pull the changes from the upstream remote into my branch called master. When I issue that command, I can see that the changes are pulled down and my branch is updated. If I want to check that my branch was updated, I can say git log and see that the most recent commit here, 5f0, is the most recent commit, 5f0, from the remote repository. You might have noticed that I told Git to pull the upstream changes into something called master. Master is just the branch that I'm working on in my local repository. I won't review Git branches right now, but I'll just tell you that if you type git branch, you can see all the current branches for this project. There's only one branch right now, and I'm on it. That's why there's a star there. I'm on the master branch. I could make other branches and have several different versions of the project on my local machine that I could do what I want with. But right now I'll just leave everything on master. And so that's why we see master show up in this command, because I'm pulling from the remote called upstream into master. So let's think about what state we're in right now. The state that I'm in is the current version of the project has 10 commits, and the most recent commit is 5f0. In my local repository, where I just ran git log, there's also 10 commits, and the most recent one is 5f0. So my local repository right now is in sync with the true version of the project. But I still see that the remote repository that I own only has 9 commits. So what I would like to do now that I have a local repository that's ahead of my remote is tell GitHub to push the changes from my local repository into my remote. For that, I'm going to use a command called git push. Git push is very similar to git pull. I can say git push to the origin, which remember is the name of the remote repository, which is this repository, from master. I want to push the changes on my master, which are the true version of the project, to the remote called origin. When I issue this command, Git pushes my local changes to my remote branch. When I refresh the page, I now have 10 commits, and the most recent commit is 5f0. Now all 3 projects, the true version of the project, my remote fork of the project, and my local branch, are all in sync. So let's pretend now that I was this user. I could skip all the steps we just did. If there was changes in this remote repository that I didn't have locally, I could issue this command, git pull origin master. In this case, the origin would be this repository, and I would get the changes into my master branch. And as we just saw, if I owned this repository, and I was this user, and I had local changes on my branch that weren't reflected in this repository, I could say git push origin master. The origin in this case would be this repository, and I would be telling Git to push the changes on my master branch to the origin. At this point in the video, I'm going to do a very similar thing to what I just did, but this time I'm going to use the GitHub desktop application, which has a graphical user interface and might be more friendly than the terminal or Git bash to some people. But let's remember that I'm not this user, and so I had to fork the project to my account. For this part of the tutorial, the way that I interact with the Git desktop application with this repo that I own will be the same way that this user would interact with theirs. The only difference will be at the end. When I get the changes here that I want, I'm going to make a pull request. But when this user makes changes, they don't have to make a pull request, because they already own the top level repo for this project. So pretending that this repo is this repo for now, let's see how I interact with it with the Git desktop client. I've already downloaded the client from the desktop.github.com website. I said download for macOS because I'm on macOS. I already started the application up, and here it is in its own window. The two things I'll have on screen now are my remote repository and the GitHub desktop client. Now I just have the remote repository that I own and the Git desktop client. I recognize the word clone from before. We issued that command in the terminal. I could clone this repo right now to my desktop, but I can drag and drop a local repository from my computer onto this window in order to add it. Let's try doing that right now. This is the same repo that has an origin and an upstream. We're just going to use the origin though. Remember, this folder exists because I used the terminal to clone it to my computer. So there already is a GitHub repo in this folder. It already has a log, it has 10 commits, it's up to date with the current project. Let's see what happens when I drag this folder into the application. I get the add local repository dialog, and it's got a path to my repository. I'm going to add that repository. In order to demonstrate how I might make changes in this repo and push them to the remote repo, what I'll do is make some changes to the folder. With my GitHub application open here, you can see most of the windows are white, indicating that probably no changes have occurred. But what if I went into the README file? I'll open that with a text editor, and I'll just make a simple change, like add a new line or add a period and save. I've now edited a file in this folder, and we already see just by bringing this GitHub application window back in focus, it's told me that what I've done is remove this line and add a new blank line and add a change to this line where I added this text and added a period. Those are the changes that I made. And just like we did in the terminal or Git bash, when we made a commit, I can add a summary. This is a description of what I just did, and I can say commit to master. Now I've made a new commit on my local branch. I can see in the history there's a new commit that says changed README. Interestingly, if I wanted, I could also open a terminal in the local folder for the repo and issue the command git log to see that that commit does exist in this repository. In fact, if I list all the files and the hidden files in this folder right here, what I see is there's a .git folder. A hidden Git folder is how GitHub tracks what is going on in this repository. When I made the change by dragging the README into this text editor and making the change, GitHub looked at the current state of that working directory and showed me the changes here. I made a commit, and this application wrote that to the .git folder, and when I asked the terminal to tell me git log, it told me that that change did exist in that local repository. So what I've just done is change the state of my local repository so that it now has 11 commits in the total history. We can see though that the remote still has 10, and if I refresh, it still has 10. So it's missing one commit. It's one commit behind my local repository. Let's look at this button here. It used to say fetch, which would have had git look at the state of the remote and then update to tell me if I was behind or ahead. But when I made that commit, it automatically did a fetch, and now it knows that I'm one commit ahead of the origin. The origin is this repository, and actually is this URL. So nice and easily here, I can just tell git to push my local changes to the origin. I can click that button, and my changes are pushed. In the terminal or in git bash, we would have ran git push origin master. That's what the application just did for us. Let's look at the remote now and see if my changes have been updated. And they have. There's now 11 commits, and if I click on that, I can see the one that I made changed README. Now that you've seen me make a commit using the Git application, let's see me make that same commit, that same change, using the terminal. The commands will be the same if you're using git bash. So what I'll do is I'll open up my README file again. So what I'm going to do is go into the project local directory on my computer and open up the README in Atom. These changes have been made. So let's say I'll add first game with Unity and remove the period and save. Let's go to the terminal, which is currently in the current working directory for the project, and let's say git status. It tells me that a file has been changed, readme md. I can say git diff readme, and it will tell me the line that has been changed. I removed this line and added a new one, or in other words, modified a single line. Running git status again, I look at this file name. I need to tell git that I want to add the changes that I made in this file to the next commit that I'm going to make. So I say git add readme md. If I had several files changed, and I wanted to add them all at once, I could say git add dot. Or I could say git add -- all. And that would add all the files that I've changed, which could be several files in several directories. It will just add them all to the next commit that I'm going to make. If I ask git the status again, I see the text is changed to green, meaning that this file, this folder, or any other folders here that were green would all be ready to be committed in the next commit. In order to make a commit on GitHub, I need to say git commit and then give it a command line argument. This is a message. What follows after -m is a space and then 2 quotes. In between the quotes, I can write, I mentioned Unity in the README. When I hit enter now, I'll see that 1 file's changed, 1 insertion was made, and 1 deletion was made, for a total of 1 line was changed. I can say git status again. I'm ahead of the origin master by 1 commit. Let's look at what the state of the repo looks like right now in the GitHub desktop application. It's already detected that I am 1 commit ahead of the origin. I can see in my history that that commit has been made, mentioned Unity in the README, and those were the changes that I just made. I just made changes to a file directly, as I normally would in any project, and then I used the terminal to tell Git to add those changes to the next commit and to make a commit on my local branch. Now that I've done that, the GitHub desktop application detects it, and I could say push origin, but in this case, I can issue that same command using the terminal. I can say git push origin master, and now the GitHub desktop application no longer is 1 commit ahead, and when I look at my remote repository and I refresh, I have 12 commits, and that commit is now in the remote repository. And finally, in this video, I'm going to cover something that's more complicated with Git, which arises all the time when you're working with a larger team or even just more than one person. And that's when different people make changes to the same project, and those changes have to be merged and deconflicted. When I'm just one person working with GitHub, every change that's made is a command issued by me, and so nothing ever gets out of sync. But let's say we have a case where I change that line in the README, and someone else in their local repository that I don't know about changes that same line. Now 2 people on a team have made a change to a README file locally on their computers, and neither knows about the other. Now they're both going to try to push those changes to the remote repository. One of their changes will get to the remote first, and the remote will have no problem accepting that change. But the second change that arrives, GitHub doesn't know which line is important for the project, and if this was a code file, which line would actually make the code work. And so the second user to push their changes to the remote will need to tell GitHub how it should handle this conflict. Whose line should it keep, or should it keep both lines? What you'll see is the user that makes changes second will have to, on their local computer, arrange the file by viewing all the changes that have occurred with that file, and then tell GitHub they want to push their changes. I'll demonstrate that process right now using mostly the terminal. So the same thing again, I'm going to open this README file, and I'm going to change this line, and I'm going to add my GitHub username. I only have one PC right now, and so the way that I'm going to pretend that another user made changes is I'm going to make changes directly using the interface on GitHub. I can do that. This is a project that I own, so I'm going to click on the README file, and I'm going to click on the edit button. You can see that my username isn't here right now on the remote. I haven't pushed the changes, so the remote doesn't know about it. To the remote repo, I'm going to add an ASCII smiley face. And I'll use this GitHub interface. I could make a commit message, but it has a default commit message, update README. I'm going to commit my changes, and we see that the change has been made. There's now a smiley face in the README. Now there's a smiley face on that line in the README, and in my local file, I have my name on that line. The remote repository has been changed, and I haven't looked for changes yet on the remote repository. Let's check what's going on with the status of my local repo. As I did before, I just need to add that file. I can add it specifically by name, or I can add all the files at once. Git add dot. I'll check the status again to see that it's green. And I'll make a commit message. I added my name to the README. Now I have, if I look at the log, a commit on my master branch. And also, when I refresh this remote, I have 13 commits, and the most recent commit is updated README. I look at the most recent commit on the remote, and I added a smiley face. Let's see what the Git desktop application tells me about the most recent commit that I've made on my branch. I added my name to the README. My local branch has a commit where I added my name, and the remote has a commit where I added a smiley face. Let's see what happens when I try to push these changes. I could use push origin here in the Git desktop client, and that's what I'll do in this case. So I'll say push origin by clicking on that button. This is what a merge conflict looks like. The repository has been updated since I last pulled. When I tried to push my changes, GitHub found new changes in the remote repository that it didn't yet know about. So it wants me to pull those changes from the remote to my local branch and get my local branch in an updated and working condition before I'm allowed to push to the remote. In order to use the GitHub desktop application to pull changes from the remote repository, I can go up to the menu and say pull. GitHub pulls the current changes from the remote repository and finds that the line that I changed in the README was also changed on the remote. And so what happens now is there's a merge conflict that I have to resolve. I'm going to say view conflicts, and I can see the conflicts here. The way GitHub is telling me about this is there is these less than signs. That's the change that I made. There's some equal signs, which separate the changes that I made with the changes they conflicted with, and then some ending lines. This part of the file is the same for both. I just need to tell GitHub what to do in this case. In order to edit this file, and tell GitHub the changes that I want to keep, I'm going to go into my text editor, and you can see that Atom has a nice way of auto-detecting the changes that have occurred in this file and the fact that there was a merge conflict. So I can just click these buttons if I want to accept my changes or accept the other person's changes. If I didn't have this nice graphical user interface that Atom just happens to provide, I could just edit the file directly. So right now I'll just pretend these buttons aren't here, and I'm going to change the file to how I want the file to look. I want the file to have bricks there, a line, a space, and a new line, and then I'll just keep the happy face there, and I'll save my changes. Go back into the application and see that the result of me resolving the merge conflict is to delete this line and keep the smiley face. It's already got a commit message in there for me, so I'll just say commit to master. Committing to master is something that I have to do. Once I've resolved the merge conflict, I commit the file to master as I would any other file to tell GitHub that I've looked at the merge conflict file, I've addressed it, and I have decided on the changes that I want to make. Now I'm 2 commits ahead of the origin because I made one commit where I added strawstack, my username, and then I made a second commit that was resolving the merge conflict. Now my branch, as you can see when I look at the file, is in the state that I want it to be in. So I'm going to push to origin again. But actually I'm going to just try to push to origin. There might have been more changes to that line that I would then have to do the same process again to resolve. But if I'm lucky, the remote has not changed since I just pulled the latest version and updated. And when I say push changes, it will smoothly integrate into the remote. So I click on push changes, and it looks like everything went through. I can confirm this by refreshing the remote. There's now 15 commits, and the most recent, I merged this branch, and there's the changes that I made. Finally now I have this branch that I just interacted with using the terminal, using the GitHub desktop application. I made a lot of local changes and I pushed them. In one case, there was a remote change, and so when I tried to push, I had to actually pull first and resolve the changes before I could push. But all that work was done to update this repository. And as I said, if I did own this project completely, I would be done right now. The remote would be in sync with my local. But since I'm actually working off a fork of the project, there's one final step. I can see that if I go to the upstream repository, it still only has 10 commits. I would like to do a final step where I tell Git to take the 5 commits that I've made and ask this user, whose repository I don't have permission to edit, I would like to ask them to pull my changes into their upstream repository. How I do that is I click this new pull request button with the 5 new commits that I've made. GitHub automatically knows this is a fork, and so it says that I would like to take the changes that I've made on this master branch and ask them to be pulled into the master branch of this user. I'll just say create pull request, and I can give it a title, and I could leave a much longer comment describing the changes I've made. I could put photos in there if I wanted, but in this case I'll just create the pull request. So that's what it looks like now. There's my title and the commits that I made in this pull request, and it tells me that this branch won't conflict. Thanks for watching my video. I hope you've learned something powerful about how to use Git.